The James Webb Space Telescope has achieved a remarkable milestone by offering a never-before-seen view deep into the heart of the universe. This time, it turned its powerful gaze toward one of the most iconic cosmic events ever recorded, supernova SN 1987A. The telescope's latest observations have uncovered structures previously hidden from view, adding new depth to our understanding of stellar death. When this massive star exploded in 1987, it became the brightest supernova seen from Earth in nearly 400 years. Located roughly 170,000 light-years away in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, SN 1987A has captivated astronomers for decades. Now, thanks to the unmatched sensitivity of the James Webb Space Telescope, we can witness the supernova's central region in stunning detail. The core is shaped like a keyhole, rendered in shades of deep blue. This region is filled with gas and dust expelled by the explosion, so thick that even infrared light can barely penetrate it. Inside this dark void lies a radiant equatorial ring, a glowing band encircling the central zone and connecting to two faint, hourglass-shaped arms. This ring is composed of material ejected tens of thousands of years before the supernova event and has since been lit up by the intense shockwave from the blast. The collision between the shockwave and the pre-existing gas created bright spots along the ring. These glowing areas can now be seen extending beyond the ring itself, dispersing light into the surrounding region. These spots mark the precise locations where the shockwave continues to interact with outer material, producing new insights into the aftermath of such cosmic explosions. What's even more intriguing is the discovery of crescent-shaped structures surrounding the supernova. These features had never been detected before and went unnoticed even by the Hubble Space Telescope. Scientists believe they are the outer layers of gas expelled during the explosion, revealing more about how these stellar deaths unfold. Despite decades of research, mysteries remain, particularly concerning the neutron star that should have formed at the heart of SN 1987A. NASA emphasized that the James Webb Space Telescope will keep monitoring this celestial remnant to uncover answers that have eluded scientists for over 3 decades. In another groundbreaking observation, the telescope has turned its attention to a dying star in the Ring Nebula, also known as Messier 57. This luminous cloud, located around 2,200 light-years from Earth, reveals exquisite structures tied to the final moments of a star's life. On clear summer nights, the Ring Nebula is visible through binoculars from both the northern and southern hemispheres, making it a favorite among amateur astronomers. However, what the Webb telescope has now shown surpasses all prior views. The Ring Nebula was selected as a prime target by the international team known as the ESSENCE Project, consisting of planetary nebula experts from around the world. The nebula's perfect size and location made it ideal for observation with Webb's mid-infrared camera, providing incredibly detailed images never captured before. Using its suite of infrared sensors, the telescope delivered visuals with astonishing clarity, revealing fine-scale structures and shedding light on the complex processes involved in stellar death. One of the most remarkable discoveries in this observation was the intricate composition of the nebula's bright central ring. It is made up of nearly 20,000 small clusters of dense molecular hydrogen, gases familiar to us here on Earth. Within the ring, scientists also found a narrow band of emission containing protocyclic aromatic hydrocarbons and other complex carbon-based molecules. This came as a surprise, as such molecules weren't expected to be present in this environment. These discoveries not only deepen our understanding of supernovae and planetary nebulae but also highlight the power of the James Webb Space Telescope in transforming our view of the cosmos. Positioned nearly 1.6 million kilometers from Earth, it continues to pierce through the darkness of space, revealing the hidden architecture of the universe in ways we could only dream of before. Beyond the luminous central ring of the Ring Nebula, scientists have observed unique peaks stretching in opposite directions from the central star. These features are most prominent in the infrared spectrum, making them difficult to detect with telescopes like Hubble that rely on visible light. Experts believe these peaks could be linked to molecules that form in the colder, denser regions of the nebula, areas that are naturally shielded from the intense radiation emitted by the dying star at the center. In these shielded zones, molecules are more likely to survive and even thrive, allowing the infrared sensors of the James Webb Space Telescope to detect their presence. The telescope's powerful instruments didn't stop there. They also captured striking details of the ring's filament structure and revealed the presence of around 10 faint concentric arcs in the nebula's outermost regions. These circular features resemble the rings of a target and appear to have formed approximately 280 years ago, an unexpected finding. No known stellar process can easily explain such a regular pattern of arcs appearing over such a specific timescale. One compelling theory suggests that a hidden companion star may have played a role. Orbiting at a distance comparable to Pluto's orbit around our Sun, this secondary star might have influenced the material ejected by the dying star, shaping it into rings as it expanded into a planetary nebula. Dr. Roger Wesson of Cardiff University explained that previous telescopes simply lacked the sensitivity and spatial resolution needed to detect these faint outer arcs. The discovery adds another layer of mystery and beauty to this already iconic object. It also reinforces the value of repeated observations, as this was not the first time the James Webb Space Telescope studied the Ring Nebula. Its ongoing observations are continually reshaping our understanding of these enigmatic remnants of stellar death. The Ring Nebula's story is also a tale of human progress and curiosity. First discovered in 1779 by astronomers Antoine Darquier de Pellepoix and Charles Messier, it was added to Messier's catalogue while he was tracking a comet through the constellation Lyra. Back then, it was mistakenly classified as a planetary nebula because of its rounded appearance. In reality, planetary nebulae have nothing to do with planets. They are the final, glowing shells of gas expelled by Sun-like stars in their last stages of life. Today, the Ring Nebula has become a symbol of astronomical discovery and cosmic archaeology. Its colorful, ring-shaped structure represents the final breath of a once bright star, now evolving into a white dwarf. In studying it, scientists are not only looking at a faraway celestial object but are also unlocking insights into the life cycles of stars, past, present, and future. In fact, it's quite possible that our own Sun will one day produce a similar nebula, about 5 billion years from now. While humanity will likely not be around to witness this transformation, it remains a poignant reminder of our shared cosmic fate. The colors seen in the images of the Ring Nebula can vary dramatically depending on the telescope and the wavelengths observed. The James Webb Space Telescope operates primarily in the infrared spectrum, which is invisible to the human eye. Raw images from Webb initially appear in black and white. Image processors later convert these into visible light representations by assigning colors to different wavelengths. This process allows astronomers to highlight specific features in the nebula that would otherwise remain hidden. Thanks to its state-of-the-art infrared capabilities, the James Webb Space Telescope is revolutionizing how we view the universe. From unveiling the structure of dying stars to peering into the earliest galaxies, it offers astronomers a powerful new lens into the mysteries of space. With many more years of exploration ahead, one can only wonder what new discoveries lie